This is a quick tutorial on the method of sections. So this is the second method of truss analysis that they do in the engineering exam. In this method, what I'm doing is I'm starting with a problem where I've got equilateral triangles, meaning they've got all 60-degree angles, and I've got 1, 2, 3 forces acting on my truss, 300, 120 and 30 newtons down, and then I've got the two reaction forces at the fixed support and the rolling support. And I've gone ahead and calculated what those are already. If you don't know how to do the calculations for the reactions at supports, then you need to go and look at the videos that I've put up online about those as well. But saying that we understand that those are the reactions, I'm going to take the problem from here. Now, if we're wanting to calculate, for instance, the value of this member over here, x, if we wanted to know what the force in that member is, previously I was showing you method of joints, where you start at one joint and then you move from that joint to the next joint, and then you can calculate what x was. Obviously, if you've got a really long bridge, that can sometimes become very tedious, and so what this method is trying to do is a shortened method which is going to help you do that. So the first thing you need to do with this kind of problem is that you need to decide that you're going to cut through this bridge. Now, the theory here is that if I cut through any part of a bridge, let's say for instance I cut through this part of the bridge here, let's chop that, and I was just to look at this half of the bridge of the cut, because this whole bridge is in equilibrium, then any of those parts of the bridge must also be in equilibrium. And so what I'm effectively going to do is I'm going to cut through the bridge, and I'm including the member that I want to calculate, but I'm going to also have to turn each of these members I cut through into a force. So that member over there, that member over there, and this one here, all of which I cut through, become forces instead of just trusses in a bridge. And at this point you kind of will generally have to guess which direction they're in, because you're not sure of which they're in. The bottom I'm going to assume is maybe a tensile. This I'm going to assume is a compressive, and this one I'm going to assume is a compressive. I'm just going to make those calls now. I don't really know what they are going to be, but I'm just going to judge them, and if my answer comes out as negative, then my assumption was incorrect. So what we're effectively going to do here is we're going to ignore this half of the bridge completely, and we're just going to look at this problem now, and it's going to have three unknown forces, x, y and z. And so what I've got to do now is I actually find this easier to redraw the whole problem as a new problem with just the trusses that are in there. So I've got a reaction over here like that, and I draw my truss, which is in blue because that's still a truss, and then I'm just going to draw my forces into this. So I've got a vertical force of 270 newtons, and I've got a downward force acting over here of 300 newtons, and I've got a force coming in this direction of unknown x, and a force that's horizontally is that z, and finally I've got another force over here called y. So it looks like I've got a lot of unknowns, but I'm redrawing my whole bridge, and I'm now going to actually just ignore the rest of my bridge, and that's what this whole method of sections is all about. So I've got three unknowns, two knowns, and I'm wanting to work out what x is. Now in this scenario, you're now going to choose moments around certain parts in this bridge to get rid of your unknowns effectively. And so what we've got to do is we've got to kind of use what we know about moments, which is if I take a point and I have a force which is a perpendicular distance from that point, then I can calculate what the moment or turning force is. But the cool things about moments is that if I choose a point and a force is going through that point, the moment is equal to 0. And so what we can do is we can calculate the values for x, y and z by choosing and cancelling out unknown forces by choosing a good point for a moment point. So if I was to use this point P over here, which I'm going to just circle, what that's going to effectively do is say, well, this force over here and this force here and this force all go through that point P. So all of those forces are going to have moments which equals 0, because a moment equals a force times a distance, and in all three cases that distance is equal to 0. So it's going to cancel those three unknowns out of my question. And so what I'm going to do is I'm going to go through this process and say, well, the sum of the moments around that point, I'm going to choose positive to be clockwise, have to equal 0, because this whole bridge is not spinning, or this section is not spinning. And if I do that, all I'm going to need to do is calculate what the vertical height is, or the distance from P to Y, and the distance from here to the 270 newtons. Now, we're going to assume that each of these trusses is 1 meter in length from our question. So our original question, each truss was 1 meter in length. There's little information left out. But if we do that, what we can see that this is quite an easy right-angled triangle. And so using basic trig, we're going to get about a 0.8 meters is height. And we're also going to figure out that that's 0.5 meters, because that's halfway between there and the next point. And so our moments over here end up being quite easy. From this point to this force is 0.8, so it's going to be y multiplied by 0.8, and that's spinning in a positive direction, so it's plus. And then we've also got this 270 plus 270 times by 0.5, because this force is perpendicularly 0.5 meters from that particular point P. And most of the students find this the hardest bit, is going, how did I pick that up? How did I get 0.5 distance from 270? And it's because it's the perpendicular distance to the line of action of that force, and the perpendicular distance to the line of action of that force. And that's the important part you always got to remember. So P is 0.8 meters from Y perpendicularly, and 0.5 meters from 270 perpendicularly. And so what you'll see here is that I'm going to bring this negative y times by 0.8 is equal to 270 times by 0.5. And if I go ahead and use my calculator to calculate some of these values, 270 times by 0.5 is equal to 135 divided by 0.8 divided by 0.8 is equal to 168.75. But you'll notice I've got a negative y now. Now what's the reason for that? Well, it's probably because I chose my sense to be the wrong way. So it looks like my sense needs to go in the opposite direction. So y is equal to 168.75 in the right hand, or the compressive direction. Now you'll need to move through x and z to finish off this problem, and I'll do that in part 2 of this video.